Question number 1. Which of the following is not true for a galvanic cell represented in IUPAC system? Yes, by observing the option, one option is given like this. Electrons are given out in the external circuit from the cathode. Which of the following statement is not true? Yes, that statement is not true. Because in galvanic cell, electrons are flowing from anode to cathode through external circuit. But in the statement, cathode to anode that is given, therefore the statement is wrong. Question number 2. A half cell reaction is one that, yes, by observing the option, a half cell reaction means it takes place at one electrode. It takes place at N1 electrode is the correct answer. Question number 3. The purpose of salt bridge in a galvanic cell is to. What is the purpose of salt bridge in galvanic cell? Yes, in galvanic cell, it used to prevent the accumulation of charges around the electrodes and facilitate the continuity of the cell reaction. And next one, to produce a current of constant strength. So all statements are correct. Question number 4. A schematic diagram based on electrolytic cell. As in the fourth question, there are 3 diagrams are given. In the diagram, we observe electrolytic cell. What is observation of electrolytic cell? Yes. In electrolytic cell, electrons are flowing from anode to cathode. Electrons are flowing from anode to cathode through external circuit. And one more, anode has a positive charge, cathode has a negative charge. Then through the solution, cations are moving towards cathode, anions are moving towards the anode. That is the correct answer, option 2. Question number 5. Yes, given a Daniel cell observed in a lab, constructed in laboratory, the voltage observed is 0.9 instead of 1.1. What is the possible explanation for this? Means, yes, actually in Daniel cell, the observed voltage is 1.1. But if concentrations are changes, this is the Nernst equation for Daniel cell. If the concentrations are changes, E is equal to 1.1 minus 0.06 by 2 into log concentration of Zn plus 2 by copper plus 2. Yes. So based upon this relation, as the given question, the value is less than 1.1. That means to get less than 1.1, Zn plus 2 concentration is more than that of copper plus 2. That is the correct answer. Question number 6. Yes, by passing a current through Daniel cell of zinc electrode, 0.13 grams of mass in 30 minutes increased in the case of decreased in the case of zinc. 0.13 grams mass decrease in 30 minutes. In the same time, if same current is passed through the copper electrode in Daniel cell, mass increases. How much mass increases? Yes, this can be calculated by the formula W is equal to capital E by 96,500 into C into T. Here W is given 0.13 if zinc equivalent weight is 32.5. C is how much? 30 into 60. Same current is passed through the copper whose equivalent weight is 31.5. Then how much weight increases? Yes, by our calculation, we got the third option. Question number 7. In the Daniel cell, which changes increases the cell EMF? We already verified the Daniel cell Nernst equation is E is equal to E naught of the cell minus 0.06 by N into log concentration of Zn plus 2 by copper plus 2. This is the Nernst equation for Daniel cell. By using this expression, to increase the E value, Zn plus 2 concentration must be decreases or copper plus 2 concentration must increase. As by observing the options, in only an option, increase in the dilution of Zn plus 2, nothing but decrease in the concentration of Zn plus 2. Yes, that is the answer. Increase in the dilution of ZnSO4. Dilution increase nothing but concentration decreases. If concentration decreases, E value increases. So the change increases in the cell EMF, so that is equals to second option. Question number 8. The electrode potential measures tendency of the electrode to gain or lose electron. If electrode potential value is more, E naught SRP value is more, that act as a strongest oxidizing agent. That means it readily undergo reduction. The SRP value is low, means readily undergo oxidation, act as a reducing agent. So it can tendency of the electrode to gain or loss of electron is the correct answer. Question number 9. Which one of the following metals will not reduce water? To reduce water, this is a reaction. If it's 2 undergo reduction and hydrogen gas releases. To get this reaction, copper undergo oxidation, hydrogen undergo reduction. But this reaction is not possible. This reaction is not possible. Why? Because copper has more SRP, hydrogen has low SRP. More SRP cation undergo reduction, less SRP undergo oxidation. But this is a reverse reaction take place. Therefore, based on the given option, calcium reduces possible, iron reduces possible, lithium reduces possible, but copper reduction is not possible. Question number 10. Arrange the following the order of the decreasing electrode potentials of magnesium, potassium, barium, calcium. This is the decreasing electrode potential order for these metals. Magnesium greater than, calcium greater than, barium greater than, potassium. Question number 11. Which of the following most powerful oxidizing agent? By observing the options, 4 options, check out the values of reduction potential. The cation which has more standard reduction potential, that act as a powerful oxidizing agent. Question number 12. Question number 12. SRP value of copper plus 2 is given, mercury is given, mercury plus 2, silver plus is given, and Mg plus 2 value is given. By the electrolysis of molten of these salts, deposition of metal at the cathode sequence order is, yes, which metal is first deposited is depending upon the more SRP. As in all these elements, more SRP is silver. Silver has more SRP values are given in this question. Silver is readily reduced at cathode first, next mercury, next copper, and the next magnesium. So that is the correct answer. Question number 13. Which of the following metal pairs are coupled will get a maximum EMF for a voltaic cell? Yes, so that is a very simple logic. You observe electrochemical series, the metal which has the lowest SRP and the metal which has the highest SRP, when these two are combined in a voltaic cell, that produces more EMF. Yes, based upon the option, iron combined with copper, copper combined with gold, lead combined with copper, and calcium combined with copper. Calcium is almost electrochemical series lowest SRP, copper highest SRP. When these two are combined, we produce highest EMF. So that is the correct answer. Question number 14. Yes, electropositivity character order is given. Magnesium greater than, aluminum greater than, zinc greater than, copper greater than, silver. What happens when copper spoon is placed in aluminum nitrate solution? Yes, we observe copper and aluminum. Aluminum has low SRP, copper has highest SRP. That means highest SRP copper undergo reduction, copper plus 2 undergo reduction, lowest SRP aluminum undergo oxidation. Aluminum is already in the oxidized form, copper is already in the reduced form. Therefore, when these two are combined, there is no reaction. That is our answer. Yes, question number 15. The given reaction is like this. X plus y plus 2 gives rise to y and x plus 2. The meaning of this reaction, X undergo oxidation, Y undergo, Y plus 2 undergo reduction. So this is possible. Highest SRP, Y undergo reduction, lowest SRP, X undergo oxidation. Yes, by observing the option, nickel and zinc, iron, SRP values are given. Based on the option, X If it is zinc, Y is nickel. So that is the correct answer.